All right, Algebra 2, the fun is beginning. After this, there is a video on how to use a calculator, but you will have to know how to do this in expanded form as well. So the first thing we're going to talk about is what a lesson 11.4 is about. We are talking about series and sigma notation. Sigma notation, you guys have seen the sum. I think you guys remember a poster that says I ate some pie and I loved it or something like that. That's what sigma notation is. It's this funny looking E that you see here on example 1. So our essential question is, can you identify series to use sigma notation? The first thing we're going to do is learn how to use sigma notation. So sigma notation looks like this. This is the upper limit, which is 5. The lower limit, I, is equal to 1. And in this case, I is not an imaginary number. It's just a variable. And then this is the equation that we're going to work with. So what this is saying is we are going to start, I'll write in a different color so y'all can see. We are going to start with 1, 3 times 1 plus 1. And we are adding it all the way till we get to 5. 3 times 2 plus 1. Added to 3 times 3 plus 1. Added to 3 times 4 plus 1. Added to 3 times 5 plus 1. Ooh, I ran out of room. So 3 times 1 plus 1 is 4. 3 times 2 plus 1 is 7. 3 times 3 plus 1 is 10. Yes, we are going up by 3. So the next one will be 13. And the last one will be 16. Now, in this case, they're just asking us to write it in expanded form. So this is what it looks like in expanded form. So please be aware they're not asking us for the answer here. Now, if I had to answer in the answer, I would just add these. Notice these add up to be 20 and another 20 and a 10. So you guys could probably add that to get 50. But that's not what it's asking. It's asking us to show expanded form. So that's what I did. Now it gets a little bit more confusing when you have to go the other way. For some reason, my pre-calc always struggles on this. So notice we have here 1/3 plus 2/3. Well, sometimes we don't notice that that's 3/3, 4/3, 5/3, and then this would be 6/3. So we have to go ahead and write this in sigma notation. We have to decide what the equation is, where do we start, and what the equation would be. So I know if we went from 1 to 2 to 3 to 4 to 5 to 6, I know that my upper limit is 6. And I'll just say that my lower limit is 1. I'm going to use x as my variable this time because you guys like x. So what's happening here? What am I doing with x? So notice all of them have a common thing of being divided by 3. So notice that I'm just going to put x divided by 3. All right. Let's look at number 1. We're just going through some things right in expanded form. So I'm going to let you guys pause me, and I'm going to let you write it in expanded form. All right, so hopefully you started the lower limit being on 3, 3 plus 7, and then going to 4, 4 plus 7, and then to 5, 5 plus 7, and then to 6, 6 plus 7, and then to 7, 7 plus 7. So hopefully in expanded form you have 10, 11, 12, 13, and 14. How'd y'all do? All right, this is one that I just want you to observe of what's happening here. Again, we're supposed to write it in expanded form, but probably I'm not going to take the time going from 2 to 100. So I'm going to first show you what I want you to see here, and then I want you to watch that next video that I have that talks about how to do this in your calculator. So notice that if I have -1 to the second power, I'm putting in 2 for my case. Notice that this is going to be a positive 1 over 4. Notice my next one, I'll write it in green, is -1 to the third power. And notice that this becomes a -1 over 6. And then if I have -1 to the fourth power, what is happening? I know on the bottom, we're multiplying everything through by 2, going up 2, 3, 4, so we end up with 8 down here. So we're really adding 2. But what's happening with my exponents? Do you all notice that it's going from positive to negative to positive? This is going to be really important that you guys start to see patterns like this, because a lot of people get stuck. Oh, how do I go from positive to negative? Did I really add, how much of a tenth? Or you guys get all confused on what you're adding and subtracting. Remember that you can alternate negatives and positives. I'm going to show you one other thing that you guys know, but you don't realize that you know it, okay? Remember, if I have n squared, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So remember, these you are going up by odd numbers. These odd numbers, you'll see, oh yeah, they're going up by odds, but you're going to forget this pattern. So what I want to encourage you to do is remember this pattern going up by odd numbers right here is what we have squared. So n squared is just going up by odd numbers. So the next practice section is just telling us to write this in sigma notation. So number 3, not so shabby. If I see what's happening, I'm going up by 7. So really, I'm just multiplying something by 7. 7 times 1, so I'm going to start with 1, 7 times 2, 7 times 3. But we have to take note of where I ended. Okay, the upper limit in this case, 7 times what is going to give me 700, will be 100. All right, and the last one is kind of putting everything together. So this is really where I was trying to get to. It's asking us to write it in sigma notation. All right, I really wanted to get to this one because this is kind of combining our sigma notation with what we did with arithmetic and geometric sequences. So the first thing we know is we need to solve this using sigma notation. I know on the top is a 1. That's pretty consistent. That has not changed at all the way through. But on the bottom, something's changing. So I know that everything's being added by 2. So I know it is an arithmetic sequence. So I actually have to use the formula for the arithmetic sequence to figure it out. My first term is 5. I don't know the n, but I know that the common difference is 2. So I have to distribute, and I get 5 plus 2n minus 2. So it looks like what I'm going to put in at the bottom, if I add those like terms, I have 2n plus 3. So 2n plus 3 is going at the bottom. I know if I start with 1, so if I just check this and I put the n in for 1, 2 times 1 is 2 plus 3. But now I have to go ahead and figure out, how did I get 25? So if you need to figure out what the upper limit is by actually solving an equation, do that. You know how to solve equations. So I know that this is going to be equal to 25. So I know that n is going to equal 11. So in this case, my upper limit would be 11. So it looks like my lower limit is going to be 1. My upper limit is 11, and my equation is 1 over 2n plus 3. So we'll show that like you saw it in the purple. Great job today.